All right, good morning. Today we are covering lesson 10.1 on exponential functions. So you're going to be able to graph these. That's the primary thing we're doing here. And describe the asymptote. And again, we will review what an asymptote is. We've introduced it before, but I know it's kind of a weird word. And we need to talk about that again. And so then we're going to write also equations of exponential functions given 2 points. Okay, so those are the tasks we have in front of us. And this video supports Delta Math lesson at 10.1 on exponential functions. However, I will tell you that this particular assignment also has logarithmic functions, which is basically exponential functions where the x and y are switched. With that caveat, I think after you've watched this video, you should be able to definitely do the exponential functions. And if you understand that you're going to be switching the x and the y, so instead of the equation being y equals a times b to the x power, it will become x equals a times b to the y power. Okay, that's what you will see when you get into the Delta Math exponential functions video. I'm toying with the idea of giving you a separate IXL skill that just covers exponential functions, and depending upon how well you do with the Delta Math and the IXL skill, I may have you, I may score the one and not the other, okay, for the same assignment. All right, but in this case, the lesson, you're taking notes on it. I started the lesson with a number of you live, so we will continue with this. If you haven't seen any of it, then you're going to be writing your notes based upon this lesson alone. If you started it with the live lesson that I had begun with you, then you can pick up where you left off in the previous one, and I will mention basically where people left off. All right, be sure to upload this to me by 11:59 p.m. Saturday, and let's move on and let's look at some of these problems. Okay, so what are we doing here? We're going to graph. This is one of the big things that we're covering here, graphing. And then they want you to provide the asymptote and the domain and the range. And you may use a graphing calculator if and as needed. And I will tell you that you should use a graphing calculator. It makes it much easier to do these. Okay? All right. So this is a typical exponential function. And if you'll note, the x here is actually your exponent. So x is your exponent. Whatever the value for x is. And so because of that, therefore, the 3 dots mean therefore, this is an exponential function. Okay, so when we did these before, this is one of the earlier functions that we tend to cover, and there was some of this in Algebra 1, and then Semester 1 we covered them. Basically, to graph these, you set up a table of values, like you would with a linear equation or a quadratic equation. Table of linear values is the way to go. So what I'm going to do here is I'm going to create a table of linear, or a table of x and y values. This isn't linear, this is an exponential function, but it still can use a table of values. So we'll set one up. Okay. All right, so you got x and you got y. And we're going to start with something easy with this. So let's start with 1. If my x is 1, that means I'm going to have 2 to the 1. So I'm going to write here 2 to the 1. And 2 to the 1 equals, well, it equals 2. We know this. That's the most obvious one I think we can show here. Now, what if your x was 2? Well, if that's the case, then you have 2 to the second power, or 2 squared. And 2 squared, everybody knows 2 times 2 is 4. Pretty easy. 3. 3 is 2 to the third power, because all of these x's are powers, or exponents. 2 to the third is 2 times 2, which is 4 times 2, which is 8. Okay? So those are pretty self-evident. What happens, though, if your exponent is 0? A lot of people forget what 2 to the 0 is. And so you can think about that, what 2 to the 0 is. Give you a moment to think about it. Well, if you aren't sure, this is why we have graphing calculator. All right, so I'm going to go over here and let me turn this thing on and clear. And I'm going to type in 2, and then remember, if you want to create an exponent, you press the caret button, and we put a 0 in. 2 to the 0, and 2 to the 0 is 1. 2 to the 0 is 1. So any number to the 0 power is 1. So 3 to the 0 is 1. 23 to the 0 is 1. 6,432 to the 0 is 1. 1/16 to the 0 is 1. The square root of 3 to the 0 is 1. Okay? So you got to get that into your head. Anytime you have an exponent of 0, then 2 to whatever the number is to that power is always going to be 1. Right? Important stuff. All right. Now let's keep going. Let's go lower in the exponents. So what's lower than 0? Well, the next number would be -1. So that means I'm going to have x to the -1. Again, do you know what x to the -1 is? Most people don't. Use your calculator. So 2 caret again. Whoops, clear this. 2 caret and then -1. That's 0.5. Now that's a decimal. We want a fraction for this because it's easier to kind of see what we're trying to do when we graph. You know, 0.5 I know I can find pretty easily on a graph, but if it's 0.625, that's a tough one for a lot of people. So, or I don't know, 0.7205, you know, all that is a problem. So I'm going to go over here to the math button. You see that math button? And I just click on it, and it says frac and number 1. So since frac is on number 1, that's what I want. I want to change this to fraction. That's what frac means. So I have the answer, and I'm fracking it. And then the answer is, you know, 0.5 is 1/2 when you frac it. So we're going to write 1/2 here. All right? Okay, so now we're going to do -2. So -2 is your exponent. So oh, I did it. I was trying not to do this. I always have a tendency to want to put the x as the base. Okay, this is 2 as the base. That was 2 to the -1, as this is 2 to the 0. So this one is 2 to the -2. Okay, so 2 to the -2. 2 caret -2. Hit enter, and you get 4. Oh, wow. Okay, 4. Things are looking up because they're going up. So let's try negative 3, and this is the last one we're going to do. So 2 to the negative 3, that is in this table, is going to be 2 caret negative 3, and hit enter on that, and you get 0.125. Okay, so I'm going to frac that because I want a fraction. Oh, did I do that right? I did positive. Okay. I put 2 to the negative 3, and I did 2 to the 2. Both of those are wrong. These are negative exponents. So the x should be, the 2 is well, no, that's right. This is 2 to the negative 2. No, this was 2 to the 2. This one was wrong. So let's go back to this one here, 2 to the negative 2. Let me rewrite that. So let's clear. So 2 caret and then negative 2. I didn't put in the negative 2. Okay, that's 0.25. And let's frac that. So hit math and then frac and then answer frac, and you get 1/4. Okay, that looks better. 1/4. So 2 to the negative 2 is 1/4. Now, negative 3. So 2 to the negative 3, because our x is the negative exponent. So 2 caret negative 3 is, again, 0.125. Let's frac that. So we click the math button. And we hit enter on frac, and we hit it again, and we get 1/8. Okay? So this is 1/8. Now, if you notice, you start out here where the exponents are positive numbers, the answers are whole numbers. When you get to an exponent of 0, of course, your answer, your output is for y is 1. But then when you get into the negatives, all of a sudden you get these fractions. And if you'll notice, basically they're the reciprocal of the 2 that you see above. This is 2 over 1. That's for x, for 2 to the 1, you get 2. For 2 to the negative 1, you get the reciprocal of 2, which is 1/2. For 2 squared, you get 4. For 2 to the negative 2, you get the reciprocal 1/4. For 2 to the 3, you get 8. For 2 to the negative 3, you get 1/8. So something to recognize, understand the dynamics of that. All right. Oh, I forgot to tell you that the big number down here is always the base. But the pure form of this exponential function, I'll just write it down here. So it's your generic one, if you will. Is y equals a times b to the x, where this is any number and b is the base, and b is always, because b is the base, as I said, and it's always greater than 0. So b is greater than 0. All right. So let's just go ahead and graph this. Okay, so we've got 1, 2, 3, 4. 1, 2, 3, 4. And we'll do, let's see, 1, 2, 3, 4, 5, 6, 7, 8. That's my y. This is my x. Okay, so what we're going to do now is we're just going to plot points. So let's start with a small one. So I've got -3. X is -3, so I go over here to -3. And my y is 1/8. So I'm going to go up on the y only 1/8, and that's just above the line here, because this is where y is 1. So I'm about, I don't know, here. Okay. And then I'm not going to put the x and y ordered pairs in these because there's too many of them, and it just will be too hard and cluttery to see it. So let's just do it the way I'm doing it. So x is -2, okay, so -2, and we get 1/4 for the y. So 1/4 is just barely above where we were before. So it's something like this. And then we get -1. So -1, x is at 1/2. So that's, I know this is not very kosher here. It's a little bit off, but it's roughly there. And then let's go to 0. So where x is 0, y is 1. Oops, I did that wrong. This one goes over here. And then here's where x is 0, y is 1. Okay, so you can see, just starting this, that you're looking to develop something that looks like this. Okay? And this goes down here, sort of close to the edge. I know that's pretty messy, but that's what it is. And then where x is 1, y is 2. So here's x is 1, y is 1, 2. It's right here. And then where x is 2, y is 4. So here's 2, 1, 2. And this is 1, 2, 3, 4. So it's over here. And then x is 3, y is 8. Now here's 3. 1, 2, 3, 4, 5, 6, 7, 8. It's about somewhere around here. So you can see what's happening is this kind of ramps up. It doesn't go vertical completely. It's just kind of going like this. All right. And so as it gets close to the x-axis, you'll notice it gets closer and closer, but it's never going to get to 0. I mean, we can go out 1,000 miles and it still won't be at 0. It would be at the y would be at some infinitesimally small fraction, but it still would be above the x-axis. Okay. Having said that, there's an asymptote that runs through, and the asymptote is the spot in between. And for all intents and purposes, it's where x is 0. So what we do is we simply write that the horizontal asymptote is going to be y equals 0. And so that's horizontal asymptote. I'm going to write it up here. HA is going to be our lingo for horizontal asymptote. And, so imagine, let me see if I can find I don't have a different color, unfortunately. Let's just use the pen, the blank pen. So if I were to just put a dashed line through my x-axis, that's where y is 0. That's my horizontal asymptote, okay? And so we can write down here that the horizontal asymptote, again, is y equals 0. And what's happening here, this is ramping up. It's like a ski slope, you know, or ski jump. Think of the Olympics. You go up in the air and you fly. That's a little extreme. Probably you would see these in Magic Mountain rides or something. But this is growth. This is what we call exponential growth. It starts very going up very slowly, but then it rapidly ramps up. That's what exponential growth does. Okay. All right. So now we want to find the domain. So we're going to use D, and remember that's for x. The x would be, you know, think of a picture frame here, and here's your graph, and where does it end? Where does it start on the left? Where does it end on the right? Okay, and you go left to right because you're going from the lowest values to the highest values. So the domain of x, we'll call that domain. And so domain, it's going to be, well, you'll notice this is going off here forever and ever, keeps on going. So it's negative infinity. And we show this like this, okay? And that's going to be less than your x value, which is less than positive infinity. And notice this is kind of a sideways 8. This is what they use. And this kind of notation is called inequality notation. So I'm just going to make that note. Inequality notation. And then another way to do this is to use parentheses. And, you know, because the asymptote doesn't quite touch the graph of the exponential function, it just approaches it. This parentheses denotes that, okay? Meaning it tells you that's what's going on. Can't get this to do it right. There we go. Negative infinity, comma, positive infinity. Okay? All right. And that's what we call interval notation. So I want you writing this out, and I want you to, you know, make sure that you understand this and you retain it, because this sort of stuff's going to be the subject of your test. You need to understand and know what these terms are, what they mean, okay, as well as, you know, how this works with a graph. Okay, so basically that's what you've got going there. Now going back to the generic thing, this is what's happening where your b, your base, is greater than 0, you get growth. Okay? That's the growth situation. So that's what this is, growth. This is showing the growth. If the b is some number, the base is some number greater than 0. Okay. What was I going to say? You know, I'm wrong about that. This doesn't show the growth. So growth occurs when b is greater than 1. B has got to be greater than 1. But your b must be greater than 0. Okay? always the base, the b must be greater than 0. So even over here, this 1/2 is the base, it's greater than 0. All right? So no matter what you're using, you got to have a base number that's greater than 0. But if b is greater than 1 and 2 is greater than 1, obviously, then you have exponential growth. All right. Now, let's look at the second one over here. So we're going to do the same thing where we're just going to, one other thing, quick thing. You know, we said a times b to the x. A is any number. I was going to tell you, you know, hey, what's going on here? Why do we only have a 2 here? Just the base. That's the b. Where's the a? Well, it's implied. The a is 1. Whenever you never see it, that's your a. And so that's an implied a. So it's the same thing over here. This is the implied a. Okay? Let's go ahead and set up a table of values. All right. So in this case, I'm going to use -2. This is my axis. -2, -1, 0, 1, and 2. And we don't need to go any further than that, so I'll just cut that off. So if x is -2 here, that means that your output is going to be 1/2 to the -2. So 1/2 to the -2, use your calculator. So I'm going to put the 1/2 in parentheses like they did here. So parentheses 1 divided by 2, close the parentheses, then the caret, and then -2. And you'll see I get 4. Okay, equals 4. Interesting. Now -1. So that means I've got 1/2 to the -1. So parentheses 1 divided by 2 is 1/2, caret -1, and hit enter, and I get 2. Okay, going down. As, oh, that's interesting, as the exponents get higher, because these are going from lowest to highest, the answer is going from highest to lowest, or it appears to be. Let's see if it holds true. Well, this is 1/2. Let me put these in parentheses. Okay, so the next one is, let me move this down just a little bit. 0, 1, 2. So this one here is 1/2 to the 0, and if you remember, any number to the 0 is 1. Okay? Again, we can prove that by using the calculator. Parentheses 1 divided by 2, close parentheses, caret, and a 0, and you see you get a 1. All right? Now, 1/2 to the 1. Well, any number to the 1 is its own number, so this is 1/2. I don't think we need to do that one in the calculator. Let's do 1/2 squared. 1/2 squared, well, 1 times 1 is 1, 2 times 2 is 4. It's 1/4. So if you notice what's happening here with the fraction, okay, as the exponent gets higher, the value gets lower. Okay, it's the reverse of this. You can see that. All right, well, let's see what the graph looks like. So, okay, so we've got -1, -2, and then over here we've got 1, 2, 3, 4. And we'll put our little X over here and our arrow, and this is our Y. We don't need to go into negative land just from looking at these. So, okay, if X is -2, that's over here, -2, Y is 4. Oh, we do have to go up here as high as 4. So 1, 2, 3, 4. So here's 4. So 2 and 4. It's about here. And then X is -1, Y is 2. So X is -1, Y is 2, which is right here. So that's about here. Now you really only need 2 to show these. If you know which way you're going, if you're going negative, which you are, it's going to go like this. So at the very minimum, you got to come up with 2 of these. Right? But it's best to do something like this at the beginning just so you see how the progression works. Okay, so -2, -1, 0. So X is 0, Y is 1. So that's right here. And X is 1, Y is -1/2. So here's 1. -1/2 is going to be halfway between 0 and 1, so that's about here. You can see it's starting to flatten out now. And then 2, here's 2, and 1/4. That's about here. So you can see your graph is sort of doing this. Okay. So this is growth. This is obviously decay. And where they get that word decay, when I'm thinking of zombies, it refers to radioactive decay. So radioactive materials break down slowly over time and become inert. In other words, they no longer are radioactive, and so they won't harm the environment. But for a period of time, they decay in radioactivity, and that's where this term came from. So your horizontal asymptote is still going to be at 0. So this is the horizontal asymptote. Okay, Y equals 0. Okay, so we can restate this now as horizontal asymptote is Y equals 0. Our domain, again, this is for X values, looks like -infinity, +infinity again, right? And we'll just use the interval notation. So parentheses, -infinity, comma, +infinity. Notice I don't put a positive sign. You could, but it's not really done. It's implied, always implied. And then the range, that's your Y values. Again, you're going from lowest to highest, so that was left to right here, but that's down to up. So make sure you understand you're going lowest to highest, down to up. Each case, lowest to highest, lowest to highest. So the lowest would be whatever your horizontal asymptote is, so that's going to be the 0. And the highest is going to be up here into +infinity. So you put in infinity as +infinity. And that's your range. Okay? All right. So last thing I will point out is that where b is greater than 1, you have exponential growth. But where 0 So if 0 is less than b, which is less than 1, then you have exponential decay. So you see this b here, here it is, this b is 1/2. That's less than, 0 is less than b, but b is less than 1. So that's this decay thing, okay? All right. So let's move on. Let's take a look at situation where other things are happening. All right. So in this particular situation, you've got a base of 1/5, so that's telling you decay. And this is x plus 4 is your exponent, okay? And so we're going to have to put that into our calculator as x plus 4. And then this 3 here, you should know, is the horizontal asymptote. When you regraph this, you'll see just exactly that. So I'm going to look at a table for this. So I'm going to go ahead and graph this first. So I'm going to use my y equals button here. Let me turn it on. Let's clear this. Go to y equals, and so I'm going to put f of x equals, be parentheses 1 divided by 5, so 1 divided by 5 in parentheses, caret x plus 4, so x plus 4, and then I'm not sure if this is going to come out correctly here, but let's just try it. X plus 4, and then let's toggle down. No, it's not going to do what I want it to do. 1/5 to the x plus 4. Let's see if I've got a workaround for that. That's x squared. Oh, let's try parentheses. So I'm going to go up and clear this. And so I want to do parentheses 1 divided by 5. And then I'm going to use the caret again. But I'm going to use caret parentheses x plus 4. Close the parentheses. Oops, I lost the x. I typed it, I thought. So parentheses 1 divided by 5, close parentheses, caret parentheses x plus 4, x plus 4, close parentheses, and then plus 3. We'll try that. All right, let's graph that. Oh, very interesting. Okay, so you see what's happening here. You can't quite read it down here, but these are cut up really small. The reason why the lower portion of the exponential function, which is obviously decaying, is so far above the x-axis is because of the plus 3. Okay, so what's happening here, if you were to graph this, all right, so 2, 3, 4, 5, and let's go up to 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, and let me do this. This is going to be at 3. Right? So I know what the graph looks like. What I'd like to do is I would like to figure out what the values are, and it's kind of hard to see it on here. So one way we can do this is we can actually click on the table tab. You see the table tab here? It'll create an XY chart for us. We don't have to mess around with it. So I'm gonna, it's blue, it's behind the graph key, so I click the second button to get to it. Click the graph key. And now you can see some values. So we want the ones that come up with whole numbers. So notice where x is -4, y is +4. So 1, 2, 3, 4. Here's -4. And this is 3. Here's 4. So at 4, -4, you got your first point. So it's about here. -4. And then you got, let's see what we can find here. Let me scroll up. Oops. -5 and 8. Okay, -5 and 8. So what I'm looking for again is I'm looking for whole numbers for x and y. So I popped up to x is -5, got y is +8. So -5, and then 1, 2, 3, 4, 5, 6, 7, 8. Here's 8. So it's somewheres over here, roughly. Okay, so -5 and 8. All right, so I've got 2. I could start my graph now, and I only need 2. So I don't really need to go any further with this. I know that my horizontal asymptote is at 3. So let me see if I can just dash a line here. That's my horizontal asymptote. And my graph is going to stay above that horizontal asymptote. So I will kind of sketch in here. And so then it just kind of rapidly gets closer and closer and closer and closer, right? Just above the horizontal asymptote. So I've just been able to graph this with that little information that I've got. So I know that my horizontal asymptote is y = 3. My domain would be all my x values from least to greatest. So I've got negative infinity. I'm going to use again the interval notation. So parentheses, -infinity, comma, and then goes off into positive infinity. And you're doing this left to right, left to right, left to right, which is least to greatest. Okay, and so the range, it's the same idea. In this case, you're going from, again, left to right is least to greatest. So least to greatest is down to up, which seems, backwards, but it's not. It's the least. So the horizontal asymptote is going to be your least. So that's going to be 3, because the horizontal asymptote is 3. And then it goes and keeps on going up. So it goes off to positive infinity. Okay. All right. So horizontal asymptote, y equals 3. All right. Okay, so that's all you need to really know for that one. All right, so this one, you first of all don't have decay, you're going to have growth, right? So this is growth. And you don't have a number for the horizontal asymptote, so you have to assume that it's going to be 0. And remember that that's right on the x-axis, y is equal to 0. Okay, so let's quickly set up a graph. This is a little crooked, but it's still, I got it set up at 90-degree angles. All right, so let's graph this. Let's do it first on the calculator. So let's clear this. Clear this. Whoops. Clear. All right, now everything else is clear. So I'm going to do 2 times 3 caret x minus 1, right? So 2 parentheses 3 in parentheses caret and then x minus 1. So x minus 1. Actually, let me put the x minus 1 in parentheses. So let me clear that again. 2 parentheses 3 caret parentheses x minus 1. X minus 1 close parentheses. All right. Let's see what that gives us. Aha. Okay. So you got your graph. So we want a couple of points. Let's do the table again. So let's go over here to second and table. All right, I got one down here. X is 1, y is 2. So let's just do 1, 2, 3, 4. So X is 1. Y is, we said, what, 2? So 1, 2. Okay. So that's about here at 1, 2. All right, and then x is, oh, gotta find one. Well, we know that it's got to be positive, or it's got to go up this way. So we should let's keep scrolling up in the x's into positive land. So I got to go down in this case to get to positive land. So there's 1. Here's 2. 2 is 6. Okay. So for 2, I got 1, 2, 3, 4, 5, 6. Here's 6. All right. So 2 and 6, and remember we only need 2 points. So 2 and 6. Okay. So it's kind of nice when you can only, you only need to do 2 points. And then our graph, let's use the black, it's going to look something like this. Okay. Going off into negative infinity. And we said our horizontal asymptote is right along the x-axis, where y equals 0. So the horizontal asymptote is y equals 0. And You can say it up here again if you want. Horizontal asymptote, y equals 0. I'm gilding the lily, I know that. And I'm going to put it down here. So just for the formal answer. So the horizontal asymptote, y equals 0. And then our domain, which is our x values, are going to be negative infinity to positive infinity. Moving left to right. Negative infinity, comma, positive infinity. Moving left to right. And so that's really least to greatest. So the range, again, which is your y, is going to also go from least to greatest. So the least is the horizontal asymptote of 0. And the greatest is, well, positive infinity. Okay. So there you got this one. Not too bad. This is not that hard, is it? Make sure, again, you write everything out and you make sure that you understand it. If you have any questions, you can always ask me about it. Okay? You know how to get a hold of me. Leave me an email or see me during Zoom or during class. That is if you're hybrid. Okay, so now we want to write an exponential function of the form y equals a times b to the x, given that the function passes through the given points. All right. So you got to remember what these points represent. They're x and y coordinates. So this is x, this is y, this is x, this is y. All right? And what we're going to do is we're going to kind of set these up as systems of equations. Okay? So let's start with over here, y equals a times b to the x. All right? And what I'm going to do is I'm going to substitute the x and y. I'm going to use 9 for the y. And I'm going to use this x over here for the exponent. So I'm going to use 3 there. Okay. So this would become 9 equals a, so this is 9 here, times b to the 3rd. Okay. And then this one over here, well, before we get to this one, let's solve this one. So we've got a b here that we want to get rid of. So if we want to do that, we're going to divide by b to the 3rd. Or actually just b to the 1/3. So we can do it this way, times b to the 1/3, and so we end up with what is 3 times 1 over 3? It's 1. So well, wait a second. No, that's not exactly what I want. Let me think about this a second. So, I know what I did wrong. So I'm looking at this incorrectly. So I said the y was 9, so we use this one, and then this is our 0. I don't know why I was looking over here. So our x is 0. So that's b to the 0. And b to the 0, what is that? That's 1. That's really 9 equals a times 1. And a times 1 is a. So 9 equals a. That's it. So now we got that answer. Now what we're going to do is we're going to substitute it over here. So this is going to be y equals, again, a times b to the x, but we're going to take this 9 and we're going to substitute it for this a over here. So it's going to go over here, replace that. So I get y equals 9. Now remember, this is an a, this is a 9, this is a 9, you know, this is an a. I put a little curly Q tail on the a's. So 9 times b to the x, right? And then the x is going to be 3, right? So we're going to have y equals 9 times b to the 3. Okay, so let's divide away the 9. Oh, sheesh. I forgot the y is over here. I got to change this out. So this is 576. 576. I should have done this in pencil. So yeah, our x is 3, and our y is 576. But we're using the a over here because we found out what a was, because the a's and the b's are the same. We put that over here. Okay. So now what's happened is I have 576 equals 9 times b to the third. I want to find out what b is. I divide by 9 on both sides. And you divide by 9 there. Let's see what that is. Because I don't know off the top of my head. Turn this on. Clear, 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 clear. Okay. All right. So what did I say? 576 divided by 9. And you have 64. So this is 64. 64 equals, this is of course 1, b to the third. Now, I could go ahead and say that this is the cube root of b, right? And this is the cube root of 64. But let's use exponents because they're easy. We got them. This is what we're all about, is exponents here. So remember that the opposite of the cube root, well, what you do is x to the 1/3. So now you can multiply that across. And I'm going to do the same thing over here. 64 to the 1/3. Now, what happens is the 3 and the 3 cancel each other out. You got 1 and 1, so you got b to the 1. So you end up with b to the 1. And this is the same as I said, the cube root of 64, right? So this is 4, because 4 times 4 is 16 times 4 is 64. So your answer is 4 equals b. You don't have to have the 1 there. You just take the 1 off, if you will. Okay. Now, putting this all together into your generic, you're going to take your y. You're going to leave the y as it was before in the x, but your a, you know, is 9, and your b, you know, is 4. So 9 times 4 to the x. This is the actual answer that you want. You're basically finding values for your a and your b by doing this system of equations. And so you find out what your a is, and you find out what your b is. And so this is what you're replacing here. The a with the 9, the b with the 4. Now you're going to say, well, multiply it to 36 to the x. No, 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 no. Because remember that this is basically 4 to the x. So that's 4 times 4, whatever the x is, I don't know what it is. Then it's times 9. So 9 times 4 to the x, leave it exactly like that, okay? All right, let's do another one and see if we can't make it a little bit clearer. So x is our 0 and y is 20 in the first pair, and in the second pair, x is 2 and y is 180. Give us some big numbers. So y equals a times b to the x. That's what we start out with. And what we're going to do is we're going to use 20 for y, and we're going to use 0 for x, so a times b to the 0, right? And b to the 0 is 1, so 20 equals a times 1, 20 equals a. Okay, so now you've got the first part of it. You got your a. You're going to plug that in to your generic equation, a times, let's just put the 20 in, 20 times b to the x. Okay. All right, here you're going to, your y is going to be 180, so you're going to have 180 equals 20, and your b is, I'm sorry, your x is 2, so you're going to have times b to the 2. All right, and then you're going to want to get the b squared by itself, so you divide by 20 on both sides. Well, let's see, take the zeros off. 18 divided by 2, that's 9. So this is answer is 9. So I have 9 equals, now you can divide it with your calculator if you need to. And then 20 divided by 20, of course, that's going to be 1, so you got b squared. All right, so you multiply times 1/2 on both sides. Which is the same as taking the square root of both sides. And again, you know, this is a fraction. The 2 and the 2 cancel. You end up with b to the 1. Now 9 to the 1/2. It's the same as the square root of 9, if you will. You know it's going to be 3. So you get 3 equals b. So now you have the a and you have the b. Now take your generic equation again. Put y back in as y. Your a is going to be 20. Your b is going to be 3. And remember, you have to leave them apart because the 3 has an exponent. That's your a, that's your b to the x. Okay. So what we've done here is we've used these 2 points to figure out what the actual function is in each of these cases. Okay? So that's it, ladies and gentlemen. I know it took a little bit of time, but we got it done. Take care and have a good day. Bye-bye now.